So I showed you the 9 steps to the factor label method using made-up labels so that it would force you to use the steps to solve the problem, or at least encourage you to, I guess. Now we're going to actually start applying it to some labels that are a little more applicable to chemistry, and in doing that, then you're going to come across things like metric, which you already know how to convert. Remember, we're still practicing the factor label method. Our main idea here is, can we follow the steps? Don't leave steps out, don't leave labels off, because what we're looking for is, can you follow the steps? I've just switched now to labels that are going to be a little more familiar to you. So let's go ahead and look at this problem and read it and figure out, is it a one-step problem or a two-step problem? Now that's a little easier to do with actual chemistry labels, because what you do is you look to see if the base unit is in the problem. If you see the base unit in the problem, it's one step. If you do not, it's two step. Now our base unit for this problem is liters, and then we can put on different prefixes. We can put on centiliters, megaliters, milliliters. So we have here nanoliters and we have liters. So check both what it's given you and what it's asking you for. If either one of those is just the base unit without a prefix, it's one step. So this one is going to be one step because it says how many liters. So according to the factor label method, the first step is to write the answer line and the label that you're going to label on your answer. The next step is to write the given over 1. So go back up in the problem, 872.9 NL. NL stands for nanoliter, and I'll have the sub pass out the equality sheet here in a minute, so you can look that up. Step 3, draw a conversion factor. Step 4, bring the given label down. I hesitated there so you could think about it. And on top, liters. Then check to make sure your labels will cancel. And they do. It's a funny looking liters, but it's there. Okay, so then we'll pass out the conversion sheet. On this conversion sheet, it's got the prefixes as they apply to liters, grams, and meters. Now I put all those on there, but you really only need one, because, like for instance, centimeters, there's 100 centimeters in a meter. There's also 100 centiliters in 1 liter, and there's also 100 centigrams in 1 gram. So every time you see that prefix, it will mean 100. So really you just need to know one of them, but I put them all on there just in case that confused you. So if you look for the one that has, let me switch colors here, these two labels in it, so NL and L, it tells you that 1 times 10 to the 9 nanoliters equals 1 liter. So here's our equal sign. Remember that the 1 times 10 to the 9 has to stay with nanoliters, and the 1 has to stay with liters. So which one do you put on top? Hopefully you said the 1. And then what the bottom says nanoliters, so that's where we're going to put the 1 times 10 to the 9. Now remember, if you are not using your exponent key, or even for some of you when you are, when you use the calculator, some of you will need parentheses around that. Most people probably do not, but just in case. So multiply the tops and you get 872.9. Multiply the bottoms and you get 1 times 10 to the 9. So you're going to take 872.9 divided by 1 exponent 9. Now for some of you that'll be divided by parenthesis 1 exponent 9 parenthesis equals. And I think that comes out to 8.72 times 10 to the negative 7. I say I think because I did it in my head, but that's what I'm getting. So that's my answer. Now, even though that's the answer, even if you have the right answer, if you've left out any of the steps, you're not going to get credit. So keep that in mind. Okay, and then the two-step problems are easier to pick out with the metric too, because again, if it has a prefix on it, then, and that's probably a two-step problem, one of them's going to have a prefix, but if they both have a prefix. So, like in this problem, it has MM and MM, and I did this for a reason. I wanted you to pay attention to the labels. If it's a capital M, it means mega, and if it's a lowercase m, it means milli. So you need to make sure that you know what's going on. Now, why I got a decimal in there, I don't know, but that decimal there, I'm not sure about. But other than that, yeah. So this is megameter, and this is millimeter. So they're both prefixes. Therefore, it's a two-step problem. So we're going to come over here and make an answer line. And our answer line is going to be the one we don't know, so that's the question mark. So that's the milli. So you need to make sure you make them lowercase. And then you write the given over 1. That would be the 5.60 times 10 to the negative third mega. Make sure you make it capital, meter. Then draw two conversion factors. What label goes on the bottom? Megameter. And then whatever the base unit is, that always goes to the top. So if the bottom isn't a base unit, then you put the base unit on top. So for megameter, the base unit is meter. So in other words, the base unit is, take the prefix off and you'll get the base unit. So then that has to also come down, because remember, whatever's top left goes bottom right. Top left, bottom right, all the way across. And then we're trying to get to millimeters, so that goes on top. Then look at your conversion sheet to know the conversions. And this is where you have to be really careful on the capital letter and the lowercase letters. And also, there's a funny looking U shape, which kind of looks like an M. That's micro. It's a Greek letter. So you have to be careful with that. Just draw it as a regular U. And that way you'll know it from your milli. But that's different as well. So you have to watch all those M's. So 1 megameter equals 1 times 10 to the 6 meters. And 1,000 millimeters equals 1 meter. So this one is the mega and the meter, so that would be this one. 1 goes with mega, so the 1 goes on what, top or bottom? Goes on bottom. And then the 1 times 10 to the 6 goes on top. And then the 1,000 goes with milli, so that goes on top. and a 1 on bottom. So in this problem, both numbers that weren't 1s went on top. So we really don't, no, I don't know how to say that. When we multiply the tops, that'll actually be our answer because there's just 1 on the bottom. But that's not always the case. Sometimes there's a number on top and another number on bottom. Sometimes both the numbers are on bottom. So it just depends. So just multiply the tops, multiply the bottoms, and divide. So if we multiply the tops, we get, I think, 5.60 times 10 to the 6th. And that's our final answer. So that's how you do the two-step metric ones. Again, I cannot stress this enough, you have got to follow the factor label method. You put your labels in first, then have the labels tell you whether to multiply or divide. If you're converting from, say, centimeters to millimeters, don't try and put those together into one conversion. If the base unit is not in the problem, you have to make that into a two-step conversion. Even if you know how many millimeters are in a centimeter, it needs to go to the base unit first. And the reason for that is because this is really setting us up for conversions that deal with chemicals, and those won't be as obvious. So the sub will pass out your homework now, and that is due tomorrow or Thursday, depending on when I see your class again.